Hi everyone, Queeveen here from the comfort of my kitchen. In today's video, we are going to look at the difference between a supermoon and a micromoon. I'll move through the year until we come to our next supermoon. Our micromoon is going to be just at the end of February, just at the end of this month. But before I do, I mentioned in the previous video that we don't really have any meteor showers this month. And by that, I really mean we don't have any particularly impressive meteor showers. I'll come back to the anti-helion in just a moment. But if we lean back and look at the whole sky, well, there is the December Leonis Minorids. They're not amazing. They're not the biggest, most productive meteor shower. If we click on them, we'll see, yeah, a maximum zenith hourly rate of about 5. And their maximum is way back on the 19th of December. They're still running in the early part of February, but there's really not much of them left. If we start moving through the month, you'll see that the anti-helion stays there, but nothing else really pops up. Even as we get from February into March, nothing really pops up. If we move ourselves forward towards morning time, just so we're looking at a different part of the sky, you can see the anti-helion stays there the entire time. We'll move a little bit further from sunrise, given that the nights will be getting shorter as we move through the month, and nothing really except the anti-helion again. Right into next month, we're not seeing many more meteor showers, and the December Leonis Minorids, as I mentioned, they're not particularly great. That's back into January. So the anti-helion, if we take a look at it here, we can see that the anti-helion there is in Leo. We'll move ourselves back towards the beginning of the night. A little bit more, that's still 11 o'clock, still pretty late. We can see that the anti-helion isn't moving with the stars. It appears to move in this different way. It's drifting across the sky. And this is something that happens with the radiance of meteor showers. They do move a little bit because they're based on what part of the Earth is facing into a trail of dust or gas. They're not dependent on the fixed positions of the stars or anything like that. Here we are, 24th, 25th. We can see that the moon is very, very close to that anti-helion point at around the time that it's full. And that is, well, that's related. The moon is full when it's on the opposite side of the Earth to the sun. And that's what anti-helion means here. It doesn't mean it's going against the sun, and it's not antihelion with an E. It's not moving into the sun or the beginning of the sun. Anti-helion here really just means opposite the sun, and it does mean geometrically opposite. It is on the opposite side of the Earth to the sun. So as we move around the sun, what stars are directly behind us will change because they're out there in space. Their position doesn't depend on the sun. Whereas the anti-helion point, it stays opposite the sun. As we move through space, the anti-helion point will appear to drift across the sky, really because it's in a fixed position relative to the sun. The stars aren't. And we can see that it's moving in a very different way to the planets. And for example, the moon, we can see there again, the moon very, very close to the anti-helion point when it's close to full. So the anti-helion, we can see here, 4 meteors an hour, getting about 4. It is one of 4 of these irregular or general or diffuse meteor showers. We have the anti-helion, we have the helion, and then we have another point ahead of us in our orbit and behind us in our orbit. So these are places where meteors just happen. As little bits of dust and rock fall in towards the sun, some of them get pulled into the back of the Earth. They burn up in our sky and they form part of the anti-helion meteor shower. Some pieces of dust and rock might be inside our orbit, but so close to our gravity that we're able to pull them in. We're able to pull them into our atmosphere, and they would form the helion point. Instead of getting pulled in towards the sun, they get pulled into us and burn up in our atmosphere. As we move in our orbit, we catch up to some pieces of dust and rock which get pulled into our atmosphere, but also our gravity is able to tug pieces of dust and rock along behind us, and those can end up crashing into our atmosphere as well. There's a lot of dust in space. We generally talk about space as being empty, and compared to the atmosphere of the Earth, it is. There's really not much out there, and between the little bits of dust and rock, there's hardly any atoms at all. Whereas, even if you're walking on a very clear day without any fog, there's still air molecules in the air. The little droplets of water that fill up the air on a foggy day, that's extra stuff. There's always gas molecules around us, and that's not the case in space. there are little bits of dust and rock out there, and those little bits of dust and rock can fall through the Earth's atmosphere at any time of the year, but they do tend to fall into those particular locations. They tend to fall into the anti-helium point or the helium point, or one of those points ahead of us or behind us. Now, we're going to go through a lot of lunar phases here, so I'll get rid of the ground. We are going to be looking for a change in the distance number here. We want it to come down, quite far down, down to about 350,000 kilometers, but we want that to happen when it's full. So we can see there, 363,000 and change kilometers. It's definitely quite near to us there when it's on the same side of the Earth as the Sun. But that's not what we're looking for. We need it to be quite near to us when it's full. And we can see that it's getting full there pretty close to the 400,000 for these months, but the moon's closeness to us and farness from us, it doesn't sync up with the months, so it drifts slowly over the course of the year. Once the moon reaches its furthest point when it's full, every full moon after that will be a little bit less than its furthest point when it's full, but it can take a while. We're getting pretty close here. As you can see, 364,000 and change. But I wonder if the next month will be any closer. Of course, I'll get rid of the ground here so I can follow it the entire way around the Earth, see all of its phases. There we go. That's about as close as it's gonna get. I will take the risk. We'll go forward one more month. I want to get the most super... Of course, the most super moon possible isn't always possible from Ireland. From any given location on the Earth, you might be a little bit ahead or behind of apogee and perigee when the moon is supposed to be its closest. But we can see here 350,000 kilometers away, give or take. That is about as close as it's going to get this year. I think if we go forward another month, yeah, that's a little further away, further away by a couple of thousand kilometers, which really, a couple of thousand kilometers is spare change when we're talking about distances that are this far. But it looks like there we are on the 10th, which would be October. It looks like we will be getting our supermoon in October. So to very quickly bring us back into February, or February, we'll just hop back like this. That is a little bit faster, given that we don't need to keep looking at the moon the entire time. So here we are. Looking, into Leo. That makes sense. We'll bring back the ground. And there we are. So we have our micromoon coming up just at the end of this month, at the end of February, and then almost an entire year away in October, we're going to have our supermoon, its closest approach to the Earth. So you are going to have to wait a few months. I will bring it up again when we get back around to October, but that is when we're going to have our supermoon and our micromoon. And as I'm sure you saw as we went through all of those changes, there's not that much of a visible difference. If you're just looking at it with your eyes, you're not going to notice that much of a change. But in images and in photographs, if you make sure that you're zoomed in the same amount, that everything's the right scale, then you can start to see a difference between a supermoon and a micromoon. Even then, it's still a little subtle. The difference in size isn't quite as great as the difference in brightness. So a supermoon is brighter than a micromoon by a greater margin than a supermoon is bigger than a micromoon. And the micromoon, well, I think the micromoon is a little bit more impressive maybe to see, because the moon's orbit, like many orbits in space, is changing. Mars has two moons, Phobos and Deimos, and one of them will eventually crash into the planet. Its orbit is degrading downwards. It's falling into the planet. With the moon, it's the opposite. It is very, very slowly, very, very slightly spiraling away from us. So this means that tides were stronger in the distant past. The moon is what control our tides. It might be much smaller than the sun, but it's also much closer. So the gravitational effect of the moon on our bodies of water is a little bit more intense than the effect of the sun. Because the moon is slowly spiraling away from us, every supermoon you see is a little bit less super than the last one, give or take. With the micromoons, it's the opposite. Every micromoon you see is a little further than the last one. So the micromoons that we get to see are just a little bit more micro than the micromoons that would have been seen generations ago. So I do hope that you enjoyed this video, mostly about the moon and the micromoon that's coming up. I hope you get a chance to see it. If you enjoyed this video, please do like it. And if you enjoyed this kind of content, make sure to subscribe to this YouTube channel. You can also read a little bit about these kinds of orbital things, particularly to do with the moon, in write up on my website, queeveenscontent.ie. And also to anyone who did come to the Friary on the 28th, there was a live show Sunday in the Friary in the evening. For anyone who did come to that, thank you very much. And if you're interested in coming in the future, well, just make sure to subscribe to this YouTube channel and keep an eye on my socials. Queeveens Content is also on Instagram under the same name, and hopefully I will be doing more live shows in the future. Of course, if you can't access the Friary, or if it's not your kind of place, you can also contact me through my website, through queeveenscontent.ie, and possibly arrange a different show in a different location. So thank you very much for watching, and I hope you'll join me next time.